Start a poll to get your viewers' opinions.
Show us.
Crew.
People can see us.
Crew showdown.
Pop in.
What's all that? Okay, how do I switch the camera?
Oh shit!
Why did you like it?
I was trying to flip
co-host more. Do you see? Are you joined on that?
Not yet.
You join it.
Yeah, here we go.
Tips for going live.
You had a couple people jump up and in.
Okay, cool.
Bear with us, guys. We're trying to figure out the camera.
Trying to flip the camera around.
Let's see.
It's our first live. We're about to do some networking.
You know, if you did
Real-time performance.
more.
I already did that more thing.
No.
Dang, you can't flip the camera around? The most important part is this. We're going to power up these two switches right here. Two Cisco switches. And then we're going to get these two PCs communicating. Why don't you...
Let's power these on.
Yeah, let's get one PC. Oh, so it says swipe right for viewer comments.
Oh, okay. And then swipe left to close.
Well, that means we can't read them.
They'll
Oh, there
pop
we go.
up on the screen. Tap flip on the top right corner.
Top right corner? No. Longer view video. Okay, no, we don't want to end the live. All right. So, did you turn the switches are booting up? There we go. We got some old Cisco switches here. We got a big old stack of routers. If you've seen some of my videos, you've seen that my son's studying for his CCNA. What's up, Josh?
What's up?
I'm Aaron, his dad. I'm trying to mentor him through Cisco certification. And he got a bunch of gear on Craigslist for cheap, like $7 a router. But anyway, we're going to start small, do this assignment, get these two computers talking. He's going to use his computer right here as, what is it going to be, PC letter A, Josh?
Yeah.
As PCA.
PCA and the laptop I'm going to assign as PCB.
Laptop is going to be PCB.
Yeah.
We're going to get those two switches factory defaulted like they just came out of the box and Ethernet connected. We got this top connection right here. Oh, excuse me. This bottom switch is connected to the laptop, and the laptop's taking a while to boot up. Now, what about your PC?
So PC, I haven't connected to the switch just yet.
Okay.
Which I'm doing right now.
Somebody just said, I'm Johnny K. Just said he's on the same assignment you are. That's pretty cool.
Ask him if anybody knows how to flip the camera. Drop a comment.
Oh, yeah. If you know how to flip the live camera back and forth from front facing to rear facing camera, drop a comment,
We've
please.
been sitting here for like 10 minutes.
We'd like to
figure it out.
Dude says you're a lucky guy. I've been trying to tell him he's blessed to have me. Just kidding.
All right.
Nah, we got to learn from somebody. He's got a built-in instructor right here at home.
Yeah.
I like what I do. What can I say? Okay, so laptop is booted up here. We could find a place to prop this phone, by the way. And you want to.
Got you.
You want to.
Should I console into the switch now?
Yeah, and you want to put your console on the same screen so we don't have to be moving the camera around too much.
Now. So if you hold it, I'm gonna go ahead and get this set up. So I'm consoling in through Putty right here.
Opening up Putty.
I'm just gonna open my device manager to make sure my USB is active. Ports. So we have.
Yeah, this is how you find out what COM port your Cisco console cable is running on when you plug it into your computer. You go into Device Manager, it says COM 8, then you put that in
to the configuration
to
on
Putty. Click
serial, and then
COM 8.
COM 8, and then I'll go ahead and
some of the default settings work. Let me zoom out. Okay, good.
And we're in.
So you're on one of the switches. They've already been factory defaulted, I'm pretty sure. So, matter of fact, type show VLAN Brief to make sure that we don't have any lingering VLANs. Okay, it looks like it's been defaulted.
Yeah, we defaulted.
So this is the top switch.
Uh-huh.
I'm gonna look.
Check the second one.
Actually, no, we're on the bottom switch. So here's the console cable
Okay.
that he's using to plug into his computer over there.
So this will be S2 that we work with.
Okay, go ahead. Since we're on that one, go ahead and name it S2.
Okay. S2. All right, here we go.
Okay, yeah, host name S2. All right, and why don't you go ahead? Now we're gonna go VLAN 1 for all this stuff. Right away. We're just gonna put everything in VLAN 1, which is the default.
Isn't there one by default? So should we move it to
VLAN 1? Let's just get everything working in VLAN 1. It's basic Ethernet. Let's just start with that. As you can see, show VLAN brief shows VLAN 1 default in the top there. Yep. With all the ports on the switch are in VLAN 1. Okay. So why don't you give the switch its IP address while we're here?
Okay.
And switch 2, it says VLAN 10, but we're just doing VLAN 1 right now. We're not gonna move anything into a new VLAN yet. You're using, what is the switch to? 192.168.10.12?
12, yeah.
All right, go for it. With a /24 mask.
Oops.
And /24 just means 8 plus 8 plus 8 equals 24. So 8 bits, when you do a binary to decimal conversion, 8 bits turned on in the mask equals 255. So 8 bits, 8 bits, 8 bits, that's where you get /24. That's what we call CIDR notation, when you use a slash notation to speak about the mask. So you need to be in the SVI. The SVI right? Of the switch is interface VLAN 1, right?
Yeah.
Now, a lot of you guys are probably thinking, anybody watching is probably thinking, I mean, why aren't y'all just doing this in Packet Tracer? We do. We do it in Packet Tracer. We do it in EvenG. You can use GNS3. I even use Cisco CML, Juniper VLabs. There's so many nice virtual environments to work in.
CBT
but we got these really cheap, and it's nice to use hardware. Yeah. Sometimes when you're learning, especially, and just getting comfortable with networking. So there you go. 192.168.10.12. Okay, cool. Now,
so we're not having to create any VLANs right now. We're just
no.
assigning an IP address to the one that's already active by default.
That's right, and we'll show that on the next switch we go to, switch 1. But you didn't. When you did interface VLAN 1, that's known as a switched virtual interface, SVI.
Right.
And, somebody just asked, what are they called? The switches? I think you're asking about this. I think you're asking about the switches. They are, in fact, KISS. Cisco Catalyst 3560s. Power over Ethernet, 24 ports. So yeah, anyway, that's what kind of switches we're messing with here. All right, let's get back to this.
IP. And if I go,
show IP interface brief. Okay, no, that's cool. That's good. That's good to check. So look, you got a VLAN 1, right, and you got the IP, and it's up and up. So let's move on. Let's go to the next switch. I'm going to move the console cable. And yeah, let me get back here and move the console cable. All right, there you go.
On the first one?
Yeah, you're on switch 1.
Okay. All right, I'm gonna go ahead and name this one. So
yeah. As you can see, we moved over to another switch. The default name was switch. He just named it switch 1. Very basic, guys. Very basic. We're just going through basic setup of a switch, and we're just going to get 2 computers talking through a default VLAN. When you take these things out of a box, I know they're old, but even if you got a brand new Cisco switch, pretty much act the same, that there's always a default VLAN 1, and these things will pass traffic by default over VLAN 1. You just plug routers and PCs, servers, whatever into them. They will automatic. Switches are like that. They'll just automatically pass traffic. You have to do a few things like we're doing here to get management up to them, to get some IP addresses on them so you can manage them. But hey, I want to emphasize these IP addresses that we're putting on these switches are not to facilitate communications of these two computers. It is only so that we can later telnet or SSH or web browse these switches from the perspective of managing them.
From a remote.
Remotely.
Host, right?
Yeah, exactly. And we're going to do that from this PC or this laptop. We're going to telnet to those switches so that we can manage them, so we can stop monkeying around with that console cable. Because a console cable in the back, look, you have to have physical access. Obviously, I'm touching this thing to get you on the console. Later, when these get installed in a central office or in a cabinet somewhere or in a communications closet, you're not going to want to walk over there as a technician and plug in with the console cable just to configure ports. That's what remote management is all about. So that's why we're putting IP addresses on them, is so that you can remotely, logically connect to it. All right, so let's move on.
So we'll assign the IP address to this one.
And by the way, can you start up a clock? Flag S and type clock. Not in the router, not in the switch, but on your computer. And set the timer for like 30 minutes, because that's about all the time I've got. Yeah. For sure. And put it up here for people to shrink it down so that everybody can see how long we're going to be able to. This is about as long as we're going to be able to live stream for, folks. Maybe we'll do another one later.
All right, so VLAN 1.
Okay. Oh, Rob M4 is asking, what is your ultimate goal with this? Just curious. This is very interesting. Yeah, Rob. This is all about teaching my son Cisco networking so that he can get certified. You know, networks are what we build. Internet providers, companies build them. Don't mean to insult your intelligence, but if you're not aware, computer networks are all about computers connecting. You could even hang a wireless Wi-Fi access point off of this, which is what we're doing a lot these days. And then all your wireless devices can communicate into the network this way. Off this other one, you could connect a router. We're going to expand on this later, but you could connect a router and connect to the internet. So it's all about getting connectivity for internet and email and just various applications that we use these days. That's why we're doing it.
And segmenting the network is where VLANs come into play, right?
Yeah, that's right.
That's right.
The host is inviting you to go.
Nah.
To go decline.
Just keep it. Okay, so I'm going to assign the IP address.
Configuring SSH, the real Robert Rodriguez. We're not configuring SSH right now.
Oh, shoot.
We're going to just get IP addresses on these switches, and we'll telnet to them. Maybe we'll add SSH if we have time.
Yeah.
Okay. So what'd you do?
Added
the IP address?
IP address to the switch virtual interface. Okay,
good. According to the addressing scheme, you're going to want to do this, folks. You're going to want to plan your addressing scheme before you go and start configuring stuff. So take some time, get a plan together, get an addressing scheme together, and it makes implementation a lot faster, a lot easier. All right. So according to the addressing scheme, he has added 192.168.10.11/24. Okay, Control Z.
Yep.
WR. WR is the old school way of copy, run, start. How to save the configuration. It's kind of blurry. I hope these people can.
Closer.
Okay, hey, now from this switch to the other one, you might be able to ping it, and it depends on if that connection between those two switches is.
Don't we need to set up a trunk?
If it negotiated using dynamic trunking protocol, or if it's just going over VLAN 1 untagged, and I forget what the defaults are, but we'll see.
We can give it a shot.
Look at that.
There we go.
So the first ping had a little bit of latency, and it's because ARP had to do its thing. It had to do address resolution protocol to resolve the Ethernet address. Type show ARP.
Okay.
Type show ARP, and I'll show them what I'm talking about. Yeah, it had to ARP for .12. And it learned what its MAC address was, and then it could pass Ethernet frames. Let's look at what, according to the diagram, by the way, we're using port 1 on those.
Yeah, those are different on our end.
Yeah, they're different on our end. We're using 24 to 24 to go from switch to switch.
And then is that 0102?
And yeah, we're using, the top one is using 1, and no, they're both using 1.
They're both using 1, okay.
The PC and the laptop are on ports 1. But what I wanted to show was that right now, between the two switches, we're able to ping, and that's going across this cable. Okay? Here, do this. Watch, we'll show in real time. Hit the up arrow a couple times for the ping and do a repeat. Space repeat.
Space.
Yeah, or like 10,000 or 100,000.
Like this?
Yeah. So it's ping. The pings are going. Look at all the chatter on those ports. If I unplug this cable, obviously the pings will stop. Protocol goes down on fast Ethernet 24. And when we plug it back in, I'm having trouble because I'm holding the camera.
You got it.
Okay, now spanning tree has to listen and learn for 30 seconds. It's orange. But in a bit here, like I said, 30 seconds, it'll start pinging again.
It detected you plugged it back in because it changed it to up, though.
Yeah, the real Robert Rodriguez is reminding us telnet is an insecure remote access protocol. You can, if somebody can sniff the wire, they can learn what the password is. So that's not a good thing if you're trying to be as secure as possible. Appreciate you reminding us of that. There we go. There's our pings. We're clean and green. Blinkies. Pings are flowing. Okay, good. So the switches can communicate with each other. Let's move on.
Okay.
Your Ma 3. Your Ma 3 is telling us about Packet Tracer. Yeah, appreciate it. We love Packet Tracer. And we love them online. We love those virtual environments. Yeah.
Packet Tracer is the most popular online simulator for doing any type of virtual networking. But there's also, I think, CBT Nuggets and Boson is another good one as well that I've heard of. CBT Nuggets and Boson software is another one I've heard about.
The CML, Cisco CML is another one. Even GNS3. There's a lot of good virtual environments to make use of where you don't have to go out and acquire expensive and cost prohibitive hardware. However, we got this stuff for cheap on Craigslist. $7 a router. We got this stack of gear for $200. Dude threw in some IP phones. So, for real. All right.
Should I set up that trunk now between the two switches?
Well, we can, but let's do that when we add a VLAN. We don't need to, let's get our two PCs talking.
Yeah.
Okay, so yours is connected.
I'll probably have to assign static IP addresses.
Yeah,
right?
so add an IP address to PC A, and you're using, I think it's 192. Okay, we're not going to go with this scheme. We're in the same subnet right now. So we're going to go with the addressing that we've already used. What did you use? 10.11 and 10.12?
Yeah. No, 10.11 for S1 and 10.12. Yeah.
For S2?
For S2.
So let's go on PCA, let's go 10.101 and we'll go 10.102 for the laptop.
Okay. So, let's see.
Somebody's asking about the phones. I can't wait to fire these phones up. It's been a long time since I've messed with phones. And it's looking like we got a 7961 and another. Yeah, so two 7961s. I understand back in the day, man, like 19 or 20 years ago, I used to fire up a Cisco Call Manager Express inside of old 3600 routers, a 3640, I think is what I used. These are 2851s, 2811s, I think 2821s. And I'm pretty sure you can do telephony services in one of these. We can get power over Ethernet. So I can't wait to fire these phones up later on. That's going to be kind of fun.
You want to go ahead and show how you configure your IP address?
Yeah, let's put an IP address on the laptop.
So you come in here, on the computer. If you're on Windows, you would come in here to your network connections. And you just right-click on the Ethernet adapter.
Your Ma 3 is saying Cisco routers and switches are pretty expensive.
Yeah.
Yeah,
If you
absolutely.
get the older stuff, you can.
Yeah, this is some old
on a
gear.
budget.
This is some old gear. We got it. We got this whole stack for $200. So
So I'll come into the IPv4, which is checked on the side. Click properties. Typically by default, you have the option to obtain an IP address automatically, which utilizes DHCP. So in this case, I'm going to assign one statically. So I'll click on the use the following, and then it frees up these boxes which were previously grayed out. And then I'll come in here.
now we were going to put 10.101. We got to be on the same subnet as the switches if we're going to be able to ping the switches and telnet to them.
Right, so
Now, if you wanted these switches to be secure from these computers, then you would put them on a different VLAN. They would be on a different subnet. Like if this was customers or employees in a company and you wanted an out-of-band management network running on these two switches, you would not put them in the same subnet.
right.
Okay.
Like if you wanted to segment departments like HR from the
Yeah.
a different department.
Yeah, and
like
you
a
only
maintenance
want
team or something like that.
Yeah, and you only want the NOC or some company that's managing the network to be able to get to the management interfaces of these devices. Then you would put them in a separate VLAN. That VLAN could literally be plumbed into a secure enclave in your network, meaning behind a firewall, whereas the computers could be on public addresses or some other routing domain that goes out to the internet but is not allowed to get into the secure enclave where the switches are. But that's a lot more complicated. We just want to have basic connectivity. So did you give it an IP address?
Yeah.
Okay, open up a command prompt
Okay.
in Windows and see if you can ping those switches. First, show what your IP address is to confirm.
Sure. So I still got a 172.
Dylan Joseph Brown's going to Kent State University for cybersecurity. Yes,
Nice.
that's cool. Josh is going to
UTSA.
UTSA for cybersecurity and trying to get his CCNA at the same time. Your MA3 VLSM ARG. Yeah.
So this should
Thank
be
God for
updated.
VLSM, though. Otherwise, we'd be doing fixed link subnet masking even today, and our address space would even be more wasted than it already is. So VLSM, as your MA3 mentions, definitely allows us to do variable link subnet masking such that you can right-size your subnets using the mask and stuff to, say, for instance, this was a different subnet over here, and you had 50 computers, and you had a subnet over here that had 100 computers. You could use VLSM and create two different size subnets to right size it for what you need to do. So thanks for bringing that up. That's pretty cool. By the way, if you look at my bio, I got a link to my YouTube channel, and I do all kinds of subnetting videos in there. It might help anybody out there that's trying to learn. All right, so
I've
you
got
have,
two
hey, you know what? I
adapters
want
in
to point something out here, by the way. So there's your IP address, 192.168.10.101, and you do not have a default gateway.
Right, because there's no routing.
Some people think you've got to have a default gateway just to have basic connectivity. You do not. In this network, who sees a router? Nobody sees a router because there's not one in its purest default sense. Okay, so I'm not saying can these devices route. I'm pretty sure that the 3560 is a multi-layer device and it can route and switch. But I'm not talking about that right now. I'm talking about how they're configured right now. And for the scenario that we're building.
We're configuring them to operate just at a layer 2 function.
Just at a layer 2 for getting PCA talking to PCB. So because of that, you don't need a default gateway because you're talking within your subnet. Default gateways are only used to talk outside of your subnet. Go ahead and ping the two switches.
So
I think it was 10.11 and 10.12.
Right.
So there's
I might be waiting
10.11.
for ARP right here. Yeah.
Boom. There we go. Type ARP space dash A before you do anything else, just to show how to look in Windows at what the ARP cache is. So there we go. 192.168.10.11. You know what? If you want to look at that MAC address and verify, which one did we ping? Switch 1?
Yeah.
Show interface VLAN 1 And then over here on the router, on the switch.
Oh, right.
On the switch, show interface, VLAN 1, pipe include. Pipe include BIA. Stands for burned in address. Yeah. Look at the last 4 characters of that MAC address. 9240. Look in your Windows ARP cache. 9240. There we go. Okay. So that's what's going on. You learned ARP. You learned what the MAC address was of the SVI of switch 1. It puts it in the ARP cache. It builds Ethernet frames, and it starts sending the packets. Mm-hmm. So let's do it for
switch 2.
Yeah, up arrow. 12. And ARP does its thing. Nice. There we go. We're good to go. Now ARP up arrow for ARP --A. Now we have .12.
10, 11, and 10, 12.
And they're also very good. So telnet to one of them.
Okay.
No, right there at the command line. Right there at the.
Oh, right here, huh?
Yeah.
Telnet -L?
Nah, you don't need any options, just the IP.
Okay. 10, 11.
There we go. We can telnet.
Well,
let's go ahead and set a password real quick if you want to.
Okay.
On the VTYs, right?
Yeah.
That VTY 0 through 4 sets a password on 5 different virtual terminal lines.
It would be 0 through 15 though for the switch.
If you wanted to add a password to all of them, just hit the up arrow. Just hit the up. Yeah.
You'd be dealing with 5 if you were on a router, most likely. Right?
Horse 2937 wants to know, what are we doing?
We'll just do passwords.
We're just learning how to do computer networking, how to make computers talk over a network. Small network, medium network, large network, or the internet. It's kind of all the same, just a matter of scale. As you can see, we're on a Windows computer here, and we are communicating with device, routers and switches. In this case, switches in the network. My son is studying for a Cisco CCNA, so we're just learning over here and sharing with whoever. Right. There we go. So you set the password on the switch. You can now telnet to it from the Windows computer.
Nice.
Awesome. So now we don't need a console cable for switch 1 anymore. You can get to it. Okay, do this. I'm going to move the console cable so you can configure. Did you save the config?
I did not actually. There we go.
WR is the old school way of saving the config. It's just like copy, run, start. Okay, exit out before I.
Yeah. I did.
Okay. Let's put you on the console of the bottom switch.
Which is switch 2.
This one right here. Joker the Toker, wish I had somebody to teach me like you're teaching your son. I barely started to learn Network Plus. Hey man, get started. That's good. Network Plus is a good place to start. I never did the CompTIA certs though. But I am curious about Network Plus. I was looking through a book in Barnes & Noble the other day. It's got some interesting information. Connect with us. Stay in touch. I'll try to help you where I can. So, did you...
So this is the
that was the enable. You're going to have to...
I got to set an enable password.
Yeah, we're going to have to go back with the console cable because we forgot to set an enable password. Okay, let's get back on switch 1. Let's get that...
Alright, so enable secret.
Yeah.
We'll just do Cisco again.
Alright, save the config.
And then see if we can go enable from here. Do we have to establish a telnet connection again?
Just do enable.
Okay.
Boom.
Nice.
That quick. Nice. Okay, you can exit out of that. I'll put you on switch 2.
There you go.
WR is really good for doing the config.
So much quicker
than absolutely.
Copy run. Running configs. Sorry.
CCNA is a lot more complicated now compared to how it used to be. One of the junior guys I work with took it. Yeah, Jason McClary 526, appreciate it. Yeah, I agree, man. I looked at the blueprint. I looked at the CCNA blueprint. You're right, there's all kinds of new stuff. I got my CCNA like 22 years ago, back in 2000, and it was just a lot of routing and switching, but there's all kinds of newfangled stuff they're doing now. So anybody that's getting their CCNA, why don't you open up Cisco.com, show the blueprint real quick. Yeah. Let's see what Jason McClary 526 is referring to. Oh, that's right. You're not on the internet anymore.
True.
Never mind. We disconnected you. Maybe you can open it up on there.
Yeah.
Anyway, while you're doing that, the
be under Cisco 200.
Cisco
300.
CCNA. Yeah, I think it's 300-201, isn't it?
200-301.
200-301.
Yeah.
I said it backwards.
So be under like exam topics.
Yeah. Go to cisco.com. Yeah, there you go. There you go, right there. So, yeah, I mean, we're just doing basic networking right now, which would be included under the network fundamentals section, 20%. But, you know, automation and programmability is absolutely something new these days. Security.
You can click on these and see subcategories also.
Your MA 3 is mentioning security stuff. Right now, looking at automation and programmability, 10%. Anybody going for CCNA, obviously, you're going to want to hammer on these high percentage ones. That's 65% right there. If the CCNA requires, say, for instance, like a 70 or a 75% to pass, if you're real strong on those, you're almost at a passing level. And so, but then you'll want to pick up another 15% on security fundamentals and then dig into some of these other ones. Thoughts on if too much division via VLANs is bad? Yeah, Sparky 402. You're not just going to be creating VLANs and complications in your network just for the heck of it. You're going to have a good reason why you're creating divisions, like you said. So, the requirements that your boss or your design, whatever it is that you're doing, or even in an assignment. If an assignment says do it, then do it. But you're talking about real world, and I hear you. It'll just your situation will dictate if there's a need to create a separate VLAN for whatever. And so, yeah, that you're not just. I mean, my mode of operating in the company that I work for is I'm gonna put as much complexity into the network as I have to, no more and no less. I'm turning on protocols only when I have to, creating network designs only when we need to. So technology is there to make our life and our jobs easier, and so we're not. The more intricacies you put in the network, the more that you're going to have to learn to troubleshoot, the more that you're going to have to do knowledge transfer for the people, the other techs in your organization. The Network Operations Center is going to have to also, whoever's supporting it, they're going to have to know all the stuff that's getting built in there. So you're not just doing this stuff just because it exists. You're only doing it because there's a real need for it. So hey, let's get back to this real quick. Mm-hmm. What did we do here?
This is on the command prompt. So I'm back on switch 2.
All right.
In. I'll go ahead and set it up with a password.
No, Joker, the toker. That's not a stupid question. CompTIA, like I said, I'm not real familiar with the Sec Plus, the Network Plus, the A Plus, and I understand they've got a CSA Plus. You're welcome, Sparky. Joker, obviously with Cisco, you're going to get more Cisco exposure to their products. And I would venture a guess, some of y'all out there might know, but the CompTIA stuff is probably vendor agnostic. And so the Juniper exams, obviously they're slanted towards Juniper switches and routers and firewalls. The Cisco exams are slanted towards the Cisco stuff. So that might be a big difference. The CompTIA stuff is probably vendor agnostic. Anyway, Habity Drew. Hey, Aaron, do you, as a network specialist, care to specialize in other areas? Heck yeah, I do. I've delved into cloud. I've delved in, well, not delved. I work as a service provider engineer in an ISP, so I'm heavily service provider focused. What else? Data center. I'm very curious. I'm even certified in data center. So yeah, absolutely. I care to specialize in other things. automation. I mean, you really, to stay sharp, to stay relevant in the industry, you have to continue to learn. And so it forces you out of your what you were doing 10 years ago. As time goes on, technology just continues to evolve and change. So yeah, you have to continue to specialize in different things to stay relevant and marketable, actually. You never know if you're going to get let go from a job, so you want to be savvy in various areas. Hey, did we get this thing connected yet, by the way? We need to put an IP address on this one. Mm-hmm. So let's do that real quick. You want to hold this camera while I knock this out?
And then
I need to turn up
you'll probably want to set up IP addresses, or configure the switch ports for the interfaces, right?
We might just only have time for basic networking today, and we'll come back and put everything into a specific VLAN other than the default VLAN and do VLAN trunking at a later time. Maybe we'll just bust out a video on it and upload it. Okay, here, let's get... Okay, what IP address? 192.168?
101 was my computer, so you can probably go ahead and configure it for a 102 address.
10.102.
Text says, hey guys, how's it going? What's going on?
What do you say?
You just said, how's it going? Baby Drew says, what goals is your son pursuing? I'm in college right now, pursuing my degree in cybersecurity, and I'm a junior at UTSA, and I'm also pursuing my CCNA at the moment.
Absolutely.
So.
I like to see stuff in real time. Get out of the telnet session.
Mm-hmm.
I love to see cause and effect in networks.
Which would just be...
As we do them, as we make changes. So exit out. Just exit out. And from the command line there, hit the up arrow for ping. And we want to ping the address I'm putting on this computer over here.
You did 102?
So I want to see this computer ping the laptop when I put the IP address in. 102, yeah. -T is persistent.
Okay.
Enter. So we're getting request timeouts. Oh, wait, there we go. Destination host unreachable. Yeah, that's just reported from your own network stack. So back over here, I'm going to give a 255. Look, it puts the default mask in there. I'm going to say OK. I'm going to say OK. And you should get some pings over here. Any second now. What's going on? What's going on? Why isn't this working? Oh, do I have a firewall on? Hey, come back over here.
Baby Drew says, you guys are awesome. Great content. Appreciate the kindness. Appreciate it.
Heck yeah.
Always nice getting feedback like that.
Check this out. We're not getting pings. The first thing I think about is a Windows firewall. But I want to show you something. Since we're in the same broadcast domain, I would not be surprised if you have an ARP entry in your ARP cache and you just can't ping me because of a firewall. Control C, ARP space -A. If you have 102 in there,
I do.
Then I'm correct. So look at this, guys. This is some good. I really didn't expect this. Highlight that whole thing.
Just the IP address?
Yeah, 102. And the MAC address, what's the last three? Echo 3, Echo 6?
Echo 6.
Hey, check this out. Hold that. Echo 3, Echo 6. IP config /all. Look at my MAC address. Echo 3, Echo 6.
Mm-hmm.
You're communicating with my laptop, but you can't ping me because I think it's because of a firewall.
Oh, okay.
So hit the up arrow for pings again. Get that going. Yeah. Yeah. So if you want to hold this, I'll disable my firewall.
Yeah.
Hopefully I can figure out how to do that real quick. I think it's... Come on.
So how do we know that it's not an issue with the intermediary devices like the switches over there?
Look at this. How do we know?
Because we're able to discover the MAC address, but we're not getting a reply back.
Yeah, you know what? That's a good point. First of all, it proves that Ethernet is flowing. If you can ARP from this computer, ARP request, and this computer gives an ARP reply, such that this is true, that you actually have an ARP entry, that says a lot.
It shows that it's unidirectional, but it's not able to
No,
go back.
not just ARP request that direction, ARP reply that direction. That's bidirectional.
Oh, it is bidirectional. Okay.
So, and it proves it because you have an ARP entry, and we just showed beyond a shadow of a doubt that that's my MAC address, Echo 3, Echo 6. I mean, how else would you learn that? You can go into bridge tables, go to the switch, type show MAC, up arrow, question mark. Let me zoom in on this address table. And this will show the addresses that have been learned in the respective VLAN. Now, to get rid of some of the extra stuff, hit quit, hit the up arrow. Well, there's the answer right there, but type dynamic, PYN tab. That gets rid of some of those static ones that you see there.
Right.
And it just shows the...
There's yours right there.
There's mine, and then yours is the other one. Well, actually...
Mine's not up there, is it?
Excuse me, the other...
Because it's showing this...
I don't know, go back over here. Type
FA01 port.
Type ipconfig /all. What's your last...
10101.
Well, no, your last four...
address,
the last four hex characters are...
2DCE.
2DCE.
Okay.
There you go. 2DCE. So it tells you the ports that the MAC addresses were learned on. You could... We could correlate the MAC addresses that were learned with the ports that they were learned on, and we can see absolutely where that traffic is coming from and how those MAC addresses are being learned. You know, and I just want to emphasize again, these are right out of the, I mean, these are factory defaulted as if they just came out of a box. Okay, we'll have to stop the live here pretty soon. But Ethernet switches will pass traffic by default without doing much of anything. The IP addresses that we put on here were purely for managing them remotely. It was not to facilitate communications. Default VLAN 1 allows these things to pass traffic without doing any additional configuration to them. And we're proving that by seeing the MAC addresses flow. So get the ping going again. There you go. So let's come over here. Let's disable my firewall. Turn it off just for a moment, just to show something. I could add an entry to the firewall, but we just want to get through this exercise real quick to show basic connectivity. I'm going to hit OK on this, and look at your pings. What do we see now? Boom.
Oh, wow.
There we go. All right. Well, that's all we got for today. We're going to have to stop the live. Glad you guys could attend. I hope it was helpful. And see y'all next time.